Okay, now. The equation for just heat is mass times the change in temperature times the specific heat capacity. Let's see if we can work this out mentally, okay? All right? Yes? Specific heat capacity is the amount of heat needed to raise one mass, one unit mass, in this case kilogram of water 1 degree Celsius. So, water, the specific heat capacity for water is this. 4,180, correct? You okay with that? All right, now. So listen to what that says, you ready? It takes 4,180 joules of energy to raise 1 kilogram of water 1 degree Celsius. What did I do to get the heat? Don't answer that. Okay, let's say this. How much heat does it take to raise 2 kilograms of water 1 degree Celsius? Well, if it's 4,180
Half of that?
kilograms per, joules per degree, kilojoules per kilogram degree Celsius. If it takes 4,180 joules to raise 1 kilogram 1 degree Celsius, how much heat would it take to raise 2 kilograms 1 degree Celsius?
8,360.
Twice that, right? All right, how about this? All right, so in other words, it would be 2 times that, right? Right? Okay. How much heat would it take to raise 2 kilograms 2 degrees Celsius? How much heat would it take to raise 2 kilograms 2 degrees Celsius?
4,180. Isn't it the same?
Double that?
let's see,
Quadruple?
quadruple it.
Yeah, double the full.
Double and double, right? Well, how did you get that? Well, you did it here. 2, right? 2 kilograms, right? 2 degrees Celsius. So 2 times 2 times 2 times 4,180, right? So listen very, very carefully. Are you ready? We can do this now. You ready? To find out the amount of heat needed to raise a certain mass of matter, a certain temperature, you simply say mass times the change in temperature times the specific heat capacity. Is that hard? Can you do that? Yes.
Oh, why is heat with a Q?
Why is heat with a Q? I want you to look that up and find out. Why is heat with a Q? Excellent question. Why is heat with a Q? Look that up right now. Okay, and report back, okay? Okay, so, this is true, correct? Correct? Yes? Okay. So, which one is losing the heat? Isn't the metal losing the heat? Yes? Okay. So, we'll say M for metal, is that okay? H2O for water, is that okay? Yes? Okay, so, the mass of the metal times the specific heat capacity of the metal, times the temperature change of the metal, times the specific heat capacity of the metal, plus the mass of the water times the specific heat capacity of the water times the temperature change of the water times the specific heat capacity of the water. Okay? Equals 0. Clear? Let me do that again. I'm fumbling for my words. Heat lost plus heat gained equals 0. Correct? Easy? The mass of the metal times the change in temperature of the metal times the specific heat capacity of the metal plus the mass of the water times the change in temperature of the water times the specific heat capacity of the water, that equals 0. Do you get it? Yes or no? Yes. What's change in temperature? Would it be temperature initial minus temperature final minus temperature initial? What would you say for change in temperature?
Initial.
Final minus,
What is it?
final minus.
Final minus initial, always. Change is final minus initial. Correct? Okay. So, let's write this out. I wanna set them equal to each other, okay? Is that okay? Not only that, but I'm going to put in delta T as well. Is that okay? You all right with that? Okay? So, this is gonna be mass of the metal times TF minus TI of the metal times the specific heat capacity of the metal. You all right with that? Equals, if I'm putting that to the other side, what is it becoming? What do I have to do to get it to the other side according to algebraic rules? I have to subtract it, right? So it's going to be negative mass of the water times TF, TI of the water You okay with that? Are you okay with that? Yes? Okay? Easy? So far so good? Well, that's really the final equation right there. That's really the final equation. I don't want to get it any more final than that for reasons I will show you, but that's really the final equation. So I'm going to stop this now so I can erase the board, okay? And I'll come back, because you know what I'm afraid of? I'm afraid that's going to stop recording and then I'll be shema shema in the middle of something, okay? Blah, no, blah, okay? Be right back.